So basically, I will start with week one. Okay. Uh, Welcome you all again to this summary session. So if you have any questions, please feel free to ask. So regarding the live session one, the question actually it was a very basic type of question. Assignments were very basic, like what are the radiation wavelength, all those things about solar radiation, etc. So, like first question was the portion of radiation spectrum emitted by sun in the wavelength between zero point 0.4 micrometer to zero point 0.7 micrometer is called. So, you all know it's called visible radiation between zero point 0.4, and then there are ultraviolet radiation and there are infrared radiation. Okay, so hello, yeah, yeah, yes, you ask. Mm-hmm. Lot of problems in all the assignments, like problems like. Mm-hmm. Yeah. So see, what I can say that if the questions in the final exam will be of somewhat same pattern of the assignments only. Okay. So the like some of the assignments has the formulas given itself in the question, which you must have noticed. Okay, so the big formulas will be given in the exam, but other formulas like smaller ones or like energy balance one that you have to do by yourself or you have to memorize them. No, 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 no. There won't be any separate seat. Okay, okay. Any other questions? See, yeah, the question which we are discussed in throughout this week, like throughout all the 12 weeks, were from the previous year assignments only. So whatever I am discussing now, like for week one, this, yeah, sure. It's, but we also don't have this PDF solutions. We no, we don't have these. We generally solve these assignment questions. We get the assignment question from the course tab, and then we solve them, and then we put them in the slides. Okay, so maybe you can contact the course TAs. Like there must be if you can put it on the discussion forum, so they may help because they have more access to the course. I also don't know whom to ask because this whole thing is that we are only assigned this interaction session where if you have any doubts regarding the course or if you want to ask anything and previous year assignment questions, we were asked to solve the previous year assignment question in front of you so that you guys can have a good understanding about the concepts that are being discussed. So this is our work, and the course TAs are there that actually goes through your assignments, your uh, everyday tasks. So I also don't know them who are the course TAs. So you can ask it on the discussion forum. Put it on the discussion forum like I am facing difficulty. Can you provide me the solution of previous year assignments? in a PDF form, because I don't think you will require a PDF form, because mostly we have solved those assignments in the weekly questions, in this live interaction session. So one thing I can suggest, that these assignment questions are not so difficult. If you have gone through the lecture slides. Yeah. No, 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 not theoretical. I have solved the numerical questions also. So this is what I am suggesting, that the assignments which are given, or the question which are given in the assignments, most of them can be easily solved by the numerical question. Even some of the lecture slides also contains the difficult question that you can apply to this. Just in the same form with changing numbers, they have put it in the assignments. So go through them. So, have you gone through the lecture slides? Yeah, sure. So that's a good marks actually. So, so don't worry if you have gone through the lecture slides, if you have gone through the assignments, you can easily get the maximum marks. So it's not a very difficult question. Just try to solve the assignments. The question are more of a similar nature. So don't worry. Just you are going great, okay? And any other questions? Okay. So. Okay. Nishit, do you have any questions? Yeah, Nishit, actually the same thing I was discussing with Mr. Sivachandran. So yeah, first thing I want to clarify that if you see the assignment question, those doesn't use very complex formulas. Only the simple formulas will be used. Like a single line formula will be used. Even if you can point out, I can solve it here itself and then show you. Those are only single line formulas you can easily apply. The complex formula which you almost, almost similar nature. I don't set the exam question paper, it is set by the professor, but I know it's almost similar nature. If you have gone through the assignment, if you have gone through the lecture slides, you will be easily able to solve them, okay? And regarding these complex formulas which you're talking, I agree with you. Slide does have complex formulas, but those are the derivations for those complex formulas. Like you write the energy equation, the momentum equation, and then you solve energy balance, then you solve and get a formula. So the last formula which is to be used in the assignment, that you have to memorize. Okay. Cause that's a big formula. So so uh, so so what you can do, what I am suggesting. So when we were studying this in my masters, so we also had to memorize them. There was no alternative. We had to memorize them. Okay, so what you can see, like if if the surface is horizontal, then beta value will be 0 or 90 degree based on the vertical or horizontal. So substitute it in the formula, okay, and get the value. So this is what you just have to memorize the main formula, where you can put the beta value, phi value, based on the latitude angle. So these things. I know it's a weak formula, but the one thing which you can do, I suggest that one thing which you can do to memorize them, what I have done in my masters, I generally try to solve question as much as I can. So after solving question, up 2 3 question, you will memorize that formula by yourself. Okay, so if you don't get any question, I suggest a book called Solar Energy by Professor Sukhatme. So that's a very good book. You can refer to that. Okay, so if you can take, I have no idea. Like if you see the portal, like can you see my screen? Okay, let me take you to the portal and see if there are any assignments or announcements. Sorry. So examination it will be issued 1 or 2 or 3 days before the examinations. Generally, what happens, whatever center which you have given as a preference, so that is generally uh, allotted. So we have assignment question, announcement for exam, announcements. Smarts, problem solving, problems and live interaction with course instructor. Okay, Professor Kalita was there. Exam format. So see, can you see the exam format? So type of exam. Okay. So generally it's a 100 marks paper exam. So uh, you can expect 60 to 70 questions or something. I don't remember actually. This also I don't know remember. So it was of 3 hours I think. So uh, hmm. So this is a 12. Yeah. Okay. So this is a 12-week course. So expect a 3 hour exam. Okay. Okay. And I don't think they haven't. They should. They must provide a like. No, they haven't provided. They should provide a quite a guideline about the exam, so that may help the students also. Okay. Hmm. So do you guys use the discussion forum? Ask a question. Hmm. Okay. Like Mr. Sivachandran has actually posted a question, problem solving session. Please post the problem solving session video link in the PMR. So I think we generally post it in 1 or 2 days. Yes, please post it and we need to see the problem solved. Assignment. Okay, 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 okay. So no issue. Please, generally we post it in 1 or 2 days. So most of the time we post it. Huh? Okay, okay. So generally, see, these were actually read by me. So whatever problem solving session, so these are generally related to us. Otherwise, these are for course TAs. Proper solution for assignment 4, 5, and 6. Please provide detailed solution of week 10. So these generally handled by course TAs actually. So generally they provide like see. Someone called Devashish Datta has asked a question, so course TAs has actually answered it. So they answer it generally. You can post it, post your queries here, so they will respond to your queries. Okay. Review assignments, not peer assignments review. So they don't provide a. Like, so they have uploaded the solution here, na? Week 11. So they will upload the solution to week 12 also. So see, they have uploaded a detailed solution here also. That's great. Okay. So yeah, go on. Oh, okay, okay, okay. So I think they are providing a solution of the assignment. Generally, when I was taking this course, not this course, some other course, so they didn't provide a detailed solution also. We have to solve them. They only provided the answers while we submit the quiz. So they are actually providing a assignment solution. So I don't think that's a very big issue. Generally, if you see the assignment questions are normally like if you see this question can be easily solved by the formula. You don't have to remember a very big formula. You just total number of modules is required. So just go to lecture slides. This is for which lecture? Week 5. So if you go to week 5, you will see like number of modules formula itself in bracket. So just use that. Simple. Okay. So that's not a big issue. Even in the solution, if we see, they must have used that formula. Number of batteries. Question 10, question 10, question. See, see this was the question, na? This was. So you have to calculate the total number of batteries. So generally, this simple formula are there. This can be easily remembered, na? This formula it into SPH into AM into P into efficiency into power into area into this radiation term. So that can be easily calculated. Okay, and based on that you can calculate the load and then divide it and get the total number of batteries, etc. So I don't think you need to remember very big formulas, just simple small formulas, and try to apply your apply your conscience also, so you guys can relate the data given in the question with the formulas, or like if you see simple term, if you see you need to calculate the area of this solar cell to be installed. So if you need a power P, so area divided by one module, you can get the area of number of modules. So on similar terms, the question are there in the assignments. So that can easily be solved by your choice or by applying your conscience. It can easily be approached. Okay. So any other questions which you want to discuss? Any any concept which you want to discuss which you haven't understood or something? Okay, okay. So, okay. So what I will do, so since this is a live interaction session, so what I will do, I will go through each week and I will pick up some questions, or I will pick up some questions and I will try to answer them. So those who are not here in the live session, so a video recording will be there, so they can get benefit from that. Apart from that, what we have discussed will also benefit them. So, okay. So if we see the week one assignment questions from previous year, so these are very simple, like E equal to SC upon lambda. I don't think these are very difficult. If these type of question come in the exam, these are 3 marks. You just have to tick them and get the marks. A hot object temperature T1 is placed in vacuum chamber having a cold. The hot object cools as a result of. So C. The important term here is vacuum. So if there is vacuum, there will be thermal radiation. Okay. So generally, I put some concepts also. Have you heard about the term conductivity, heat transfer coefficients, modes of heat transfer? So I think by going through week 1 to 12, you guys must have a good understanding about this conductivity heat transfer terms. Which of the following law provides rate at which energy radiated by black body at a given temperature T? So generally, it's Stephen Boltzmann law. E equal to sigma A T4. Newton's law is for cooling, it's for convection. Kinematic viscosity of fluid is equal to, so this is a fluid dynamic concept. So kinematic viscosity, I think it's written like this, equal to dynamic viscosity mu upon rho. So dynamic viscosity upon fluid. So I put a total uh, like comparison between these two viscosity also. You can go through these slides and have a good understanding. And this was a graph, so I think we don't need to go much detail into this graph. So this was basically showing a variation of kinematic, dynamic, viscosity. So that's why I put it here, and density with Liouville fractions. So you can see how if you apply a Liouville, how this viscosity actually goes up. So it's not a like density has a linear increase, but it doesn't have a linear increase. Okay. Reynolds number is this is very important concept if you want to study the heat transfer of fluid. Reynolds number. So what is Reynolds number? So Reynolds number is inertia upon viscous force. Rho VD. Okay, so this is called Reynolds number. For a closed system, the difference between heat added to system work done by system is equal to. So if there is a closed system like this, suppose this is your room. So heat Q is added and work is done. So let's say 100 joule heat is added and suppose 60 joule work is done. Okay, so whatever the difference between these two, because energy can neither be created nor be destroyed, so this will be stored here by the closed system itself. So it will be internal energy of the system, Q equal to U plus W. So this is what is represented here. Okay, so Q equal to U, take this area U plus W. A cycle heat engine operates when. So these are very easy questions. I don't think I need to go into detail for these questions. Like if T is 800. So one thing people do a mistake here. Can anyone point out what mistake they do while calculating this efficiency? So let me tell you what they do. They will treat it as it is. Okay, forgetting the efficiency. But if you put this value here, this value here, it will give a wrong efficiency value. You need to convert it to Kelvin. Now put it here. You will get efficiency as 96.25, I think is the correct answer. Let me calculate 1073 minus 3 divided by 1073. No, not this. 71.76 is the correct answer. Which of the following instrument is used as a measurement of temperature? So, for measurement of temperature, thermocouple is the correct answer. Okay, not manometer. Not manometer is for pressure. Bottom tube is for pressure, and anemometer is for wind speed. Hmm. So air is blown over a hot plate of area this, made of carbon steel at this, so air temperature this, convective heat also, so then like Q equal to H A T minus T A. So you can calculate it. Okay. So this is how this week is completed. Let me select a tough numerical question from the previous assignment so you guys can have a good. तो वॉलेट कहाँ रखा है? घर का बाहर गया। नहीं यार, क्वेश्चन सॉल्व कर रहे हैं। Okay, so let me select a tough question. So I found a question here. Now I will share it with you. So guys, can you see my slide? Okay. So I oh yeah, I need to solve it. So basically these type of question which you guys generally face problem, like how these are to be solved, how we can solve them. Okay. So let me tell you. So a liquid flat plate collector with tube in line with the observer plate has an overall heat loss coefficient of this much. Okay. So first the data which you have, just write it down. You will equal to 5.8. Okay. And then outer diameter of the tubes are 14 mm and 18 mm. Okay. So di equal to 14, d outer equal to 18, and then uh, tube center distance is, so tube center to center distance W is given equal to 12 centimeter. And first thing which you need to do is to mind the units. These are in mm. Similarly, this is in centimeter. And fluid to tube heat transfer coefficient is, that is, H is given 205. So H is watt per meter square Kelvin. So first thing you do is to convert all these into SI units like meter. Okay. Absorbable material thickness is given 0.2, galvanized iron thickness is given 1.3, thermal conductivity of copper, galvanized iron and aluminum are 350, 35. Okay. Now you need to calculate the collection efficiency factor. So you guys are like, how can we calculate this collection efficiency factor? There are very big formulas, very um, good amount of derivation is there. So no, you don't have to go into those derivation. You can just apply collection efficiency factor formula, which is given in the slides. 1 upon WUL. Okay. 1 upon UL W minus d naught phi plus d naught, okay, plus 1 upon pi di into hf. So you just have to remember this formula only, okay. So every value you know, w you know, ul you know, d naught you know, okay, di you know, hf you know. Hf is this. Only thing which you don't know is this phi. So how can you get the phi? So there is a formula for phi also. Tan h m h minus d naught upon 2 m into w minus d naught upon 2. Okay, so you know everything. Now put the values here and get the value of phi. Then after getting the value of phi, put it here and get the value of collector efficiency factor. And what is unknown here? Unknown here is m. Okay, so for phi formula m, you need to calculate the m. Okay, m. So m equal to under root ul upon kp, that is thermal conductivity, which is given as 350/35 into delta p. Okay, so this is delta p and this is kp. Now calculate m, put it here, calculate phi, put it here, put all the values and calculate the collection efficiency factor. Now do it. Solve this question and tell me the answer. Yes, sir. Yes, sir. सर मोर गैसेस बनेंगी. यस सर. यस सर. हीटिंग रेट अगर ज़्यादा करेंगे तो ऑयल बनेगा. यस सर. हाँ. यस सर. यस सर. सर मोर गैसेस बनेंगी. मोर गैसेस. सर गैसेस ज़्यादा बनेंगी. सर यस सर. क्योंकि सेकेंडरी रिएक्शन होगा वो गैसेज में कन्वर्ट होगा ज़्यादा. 900 पे गैसेज ज़्यादा बनेंगी सर. यस सर. So what you guys can do is change the values 5.8 to 6.8 and heat transfer coefficient to 305 and this thermal conductivity as 450. Now you can try to solve it like we have solved the previous question. So when you try these questions more and more, the formulas which you will get more acquainted with and you will memorize this formula will get inscribed in your mind and you can easily recall them in the exam. Okay, so try to solve it. Okay, so I will give you time. So that's why I'm picking a big question. So you guys, it's uh, the main focus on me is not to is actually make you more comfortable with these type of questions to show you that these questions are like only big questions. These can easily be approached and solved. Okay, apply the same method and try to solve it and tell me the answer in 5 minutes. So, okay, friends. Now we'll discuss some concepts related to solar radiation map and global horizontal radiation, etc. I think let me share my slides instead of the screen will help. Okay, so this is the solar radiation map, global horizontal radiation. You can see this is equator line. So most of the sun rays are actually quite intense in this region, plus minus 15. So plus 15 or minus 15. So this is the region which has most of the energy coming from the sun, and the rest of the energy is actually distributed throughout the uh, subtropical regions, and the subarctic region actually see between 45 and 60 very less radiation. So this area is more capacity to absorb the solar radiation and generate solar power or solar electricity or photovoltaic uh, power. Okay, so you guys can have a good look at this, and if there is any question, you please feel free to type it in the chat box, or you can ask it directly. Is there any queries? No queries. Shall we move to the next slide? Okay, so this is a total figure that represents all the angle or solar angles. So basically, this is the altitude angle. This is azimuth angle. So this is observer. Okay, observer like a person or any object to which a reference is drawn for all the angles. This is the meridian lines. Okay, and this is actually zenith. So zenith angle, horizon, zenith, all those things. So all those angles are then. So if solar altitude angle, so if sun is there, so this is the ray, then whatever angle is subtend to the, this is called altitude angle. Similarly, angle due to south is azimuth angle. Okay, kindly have a look at this. This represents a semiconductor. This is the n-type doping. Okay, so here magnetic carriers are electrons, and this is p-type. And this is where the electron hole recombination happens, and this is called a depletion layer. Okay, here the magnetic carriers are holes that are positive charges, and the magnetic carriers are electrons. So this is how solar cell is actually designed. This is the basic function of a semiconductor that goes into the solar cell, photovoltaic cell. So this is basically MPPT, multiple power point tracking. So this is solar panel. Okay, so whatever power it produces goes through MPPT. And MPPT actually judges the amount of power, orients the give feedback to the controller, which orients the solar cell to the um, direction in which the rays are actually falling vertical to it, like perpendicular to it. So the more power can be generated. So it acts as a controller also, and it acts as a brain of this whole thing also. So all of things are actually connected to this solar charge controller, which has MPPT. Okay. So this is what a basic diagram of a solar panel providing electricity to the household it looks like. And one more thing, whatever power it produces is actually stored in batteries, so that because solar power is intermittent in nature, so some of the power needs to be stored so that when there are no solar power at night, so that can be used from battery and produce a direct current. So basically, all our um, equipment work on AC loads that has to be converted to DC to AC. Okay, AC to AC. So this is basically a flat plate collector. It has a glazing. This glazing is basically a glass cover that actually uh, is transparent and let the passage of um, solar. So one more function what it does, it basically converts the longer wavelength to shorter wavelength. Okay, so that solar rays are actually trapped. This is the frame, this is the tubes, and this is header. Okay, so water is goes there, takes heat, and then come back and flows out. It's okay, and this is the absorber plate. How a flat plate collector actually works. Okay, and this is basically a vapor absorption system which you guys have studied in very big 12. So this is absorber cycle and this is generator cycle. Okay, so there are two liquids, weak ammonia solution that actually takes heat and convert to strong ammonia solution. There is generator, it is a high pressure ammonia vapor that goes to condenser, so it rejects heat. Also receiver, then it expands and goes to evaporator, takes heat from the storage side, and then goes to absorber, back to absorber. So this is how it works. This is a dye sensitized solar cell. So it has this PiO2, okay, and this dye are actually stick to the surface of PiO2. This is a glass cover. This is also a glass cover. This is a counter electrode, and this is electrode. This is how it works. Okay, this was basically taught about the sensible heat. So this is basically the sensible heat, and this is called the latent heat. So this is a very important diagram. I want you guys to spend 2-3 minutes on this diagram so that you guys can understand the basic principle behind latent heat and sensible heat storage system. So this is basically a solar cooker. So this is a parabolic disk collector. So it collects the solar rays and then puts it down to this reservoir point where the cooking apparatus can be placed. And this is how the solar cooking works. Okay. Now these are various solar collector. These are solar trough collector. This is a heliostat type. So this is basically a schematic diagram of this. So there are absorber plates, steam tubes, insulation, and the sunlight is actually focused here. And this is a parabolic disk collector like solar cooker, like we seen in the last slide. Okay. Let's move to the next slide. So this is basically a solar distillation of water. So the impure water is here, then sunlight comes, evaporation occurs, and it collected here, then goes to this through condensation and collected outside. So main thing is that when distillation occurs, only the pure water goes up, and the impurities are remain here only. This is a quite a good setup in which solar energy can be used for obtaining a pure water. And one more thing is that impurities, this can also be used for this uh, saline water, like seawater, can be made pure and drinkable, potable through this. So mainly, it's a very useful apparatus. This is a solar pump. So I think most of you are quite familiar with this solar pump type of setup. So this is a solar collector. This cold water goes in, then hot water. So this is cycle through which it flows, and there are some setups in which cold water goes and then to taps. So this is actually a solar pump. So there is a controller pump actually test there. So these two concepts are actually very important. So I try to focus on this. And if there are any questions, please feel free to ask. Thank you all for this live session. So this is the last session of this course, and thank you all. You all have been fantastic students, and a lot of good questions were asked throughout this session. So once again, thank you and best of luck for the exam.